Let's say you're asked to find the probability of some input x value. Essentially, you're going to find the z-score, go to the z-table, and find the p-value, that's the probability value, and then answer the question if it's above, below, or in between. For example, IQ scores have a normal distribution with a mean of 100 and a standard deviation of 15. So the question is asking, what is the probability someone has an IQ under 120? So the formula, z equals x minus mu over sigma. In this case, our population mean mu is 100, our population standard deviation, sigma, is 15, and our input value here, x, is 120. 120 minus 100 divided by 15. 10 divided by 15, and you only want to go to two decimal places, will give you 0.67. So from here, a few things to consider is our value, 120, is above 100, which means I'm above the mean, which means I would expect a positive z-score. It's a nice little kind of self-check to make sure you have a positive versus a negative. From here, I'm going to go to the positive z-table, and I'm going to look up 0.67. So I'm going to look up 0.6 on the left, 0.7 up top, and find where they meet. And I find they meet at 0.7486. If you need to pause, do that. Again, 0.6 on the left, 0.7 up top, find where they meet, and I got an answer of 0.7486. Am I done? Well, what do they want? They want under, they want less. And if it's less, the z-table, remember, reads less. So I'm done with part A here. The answer is 0.7486. Part B, what's the probability someone has an IQ over 95? So again, I've got another question with a new input value. Find the z-score. 95 minus 100 over 15. X minus mu over sigma. Negative 5 divided by 15 is negative 0.33. So now I'm looking up a negative z-score. Negative 0.33. And so in this case, it starts in the bottom. So negative 0.3, up there is 3. Find where they meet, and I get 0.3707. Make sure you find that as well, 0.3707. It wanted over. Your z-table, remember, reads less. So you're going to do 1 minus that value to get your final answer. 1 minus 0.3707 will give you 0.6293. And they'll have it either as a decimal or a percent. So it's either 0.6293 or 62.93%. What is the probability someone has an IQ between 80 and 140? Well, we have two values, which means we're going to find two z-scores. And then from there, we're going to subtract those probability values. So here we go. If you notice, I'm calculating it twice. So that'll be negative 20 divided by 15 is negative 1.33. That'll be 40 divided by 15, which gives you 2.67. All right, let's do this. So negative z-table. Negative 1.33, so negative 1.3. 3, find where they meet, and I get 0.0918. So mark that down, 0.0918. Then the positive z. Side, 0.0918, even I'm marking it down off the side here. 2.67. So let's see, 2.6. And then 7, just double checking, 2.67 gives me 0.9962. Okay, here we go. So this would have been 0.9962. This one is going to be 0.0918. What am I going to do? Subtract them. So in my calculator, I'm going to subtract 0.9962 minus 0.0918, and I'll get 0.9044 for that one. What is the probability someone has an IQ of exactly 123? No chance. Because if it's a normal distribution, it is continuous, and we can't pinpoint exactly. There's no shaded region. All this under, over, and in between is over an interval, over a region. If there's no region, then there is 0 for the probability. So there's several examples dealing with, again, below, above, in between, and exactly when you're finding a probability from a given input x value.